Hello viewers, in continuation of my previous program where I have discussed about early magmatic ore deposits, now I will discuss in this program late magmatic deposits. Late magmatic deposits broadly defined as ore minerals crystallized from residual magma towards close of the magmatic period. Here I would like to make a difference. In previous early magmatic deposits, most of the deposits were formed in the early stage of crystallization of magma, but here in the late magmatic deposit, the ore deposits are formed in the late magmatic period. We can better call it as late magmatic period. Magma fraction left after crystallization of early formed rock silicates. You see, when early formed crystals are formed or crystallized, they get segregated or injected. Once they segregated or injected, the magma which is left out in the system is rich in silicates, and the late magmatic ores are later than the rock silicates and cut across them. They embay them and forms reaction rims of alteration products, and in this types of ore bodies you may find deuteric alteration. Deuteric alteration means primary alteration due to vapors, H2S gas, carbon dioxide, all these gases they gave rise to alteration of the previously formed or previously crystallized rocks as well as ore bodies. Late magmatic deposits associated with mafic rocks and resulted from crystallization, differentiation, gravitative accumulation of heavy mineral liquid and liquid separation of sulphide droplets called liquid immiscibility. You see, the mafic minerals they get segregated, they are left out of the system, they are not there. The magma is rich in silicates. This silicate rich magma undergoes crystallization, and crystallization along with differentiation process, and during crystallization differentiation process gravitative accumulation is also simultaneously taking place, and as a result of gravitative accumulation heavy mineral residue is separated out of the liquid and form a separate layer in the magma chamber, and whatever left out of the system, that liquid separation is there, that is mostly in the form of sulphides, and this sulphide is mostly in the form of liquid which is immiscible liquid. Liquid immiscibility is always there. This liquid enriched in sulphide is immiscible with the remaining melt, and it forms a liquid immiscibility. As a result, iron, most of them iron oxides, titanium, mostly titanium oxides and volatiles, because these silicates they are enriched in volatiles, and volatiles means the major chunk, the major proportion of the volatile is mainly water vapor, carbon dioxide, H2S, chlorine, fluorine, all gases they contribute to volatiles. So, this silicate rich liquid is enriched in volatiles in the interstices of the rock grains, forcibly squeezed out and forms residual liquid segregation of injection. Remember, when silicate liquid or silicates, maybe immiscible silicate rich liquid is there, and that liquid is always enriched in volatiles, it attains a pressure, the volatile pressure. Under this volatile pressure, the segregation and injection, the residual segregation of crystals as well as injection is taking place, giving rise to ore deposits. For example, iron titanium ores of Bushveld complex of South Africa is the best example of such types of ore forming processes. Let me show you a cross section typical of komatiite volcanic sedimentary sequence showing ore controls of komatitic nickel copper deposit. See this diagram here, there are gravic layers here, and in this gravic layers banded iron formation, this brownish banded formation layers, these 3 layers shown here, they are formed because of the late magmatic segregation, and here near this faulted paleofault active during early phase of komatiite extrusion, what has happened? The nickel copper ore deposit forms here and in the form of a layer here, and nickel copper ore deposit is separated and forms a deposit here. So, this process is contributing ore formation of sulphide deposits as well as iron oxide deposits here. This layer is tholetic basaltic layer. These deposits are covered with tholetic layers and finally covered with alluvium at the top. Now, residual liquid segregation, iron rich magma undergoes differentiation at depth. Early formed calcic plagioclase and mafic minerals in liquid will sink because of their high specific gravity. They sink down to the bottom of the magma chamber. With the propagation of crystallization, as the crystallization process progresses, there will be a mush of crystals. Crystal mush means the large size crystals, they are aggregated at one place and forms a mush. Crystal mush, diminishing liquid. What is happening with the progression of crystallization? The progression of crystallization process, what is happening? The amount of crystal mush is increasing. At the same time, the amount of liquid is diminishing and crystals will grow to the larger size. The crystal growth is also taking place in this case. So, the smaller crystal becomes larger crystal. And you see in residual liquid richer in iron and its density may exceed, there are 3 possibilities. 1. Silicate crystals grow with interstitial magnetite formation, and number 2, heavy iron rich residual liquid drains downward as segregation, and another one is late gravitative liquid accumulation. The best example is the ore deposits formed by residual liquid segregation is titaniferous magnetite of Adirondack mountains is the best example. I am citing another example here with a diagram shown over here. You see the cross section of a typical anarthosite ferrodiorite intrusion showing relationship between different forms of titaniferous or titanium concentrations. See here antiperthite anarthosite, this is an anarthosite body here, andesine anarthosite body, this is grayish blue in color and deep blue in color, both the rocks are anarthosite. They have a little difference, one is antiperthite anarthosite, the other one is an andesine anarthosite. Mineralogically and texturally they are different, but petrologically they are anarthosite. This anarthosite body or anarthositic magma through which the rutile means TiO2, the titanium ore and ilmenite is also a titanium ore, they get disseminated throughout the rocks. They get the rutile and ilmenite, both of them of titanium ores, titanium oxides, they get disseminated in the country rock and form ore deposit. See here this red colored here, red color massive ilmenite apatite deposit. This layer of massive ilmenite apatite deposit, you see interestingly, it is found at the contact of the two rocks, these rocks white colored and this ferrodioritic rock, because this is a weak plane here and along this weak plane the massive ilmenite crystals were deposited here. Now, come to the residual liquid injection. Iron rich residual liquid accumulated before its consolidation and subjected to movement under pressure. As I told you earlier, these residual liquids are under tremendous pressure. Why under tremendous pressure? Because of the volatiles. So, under this pressure the movement is taking place of a residual liquid. Such liquid is squeezed out to places less pressure into the overlying portions of the host rock or into adjacent rock, forming residual liquid injection. As these liquids are under high pressure, they exert pressure and there are weak planes, planes of weaknesses such as faults, fissures, joints or bedding planes. Under this pressure they get widened, and because of this pressure the widening of these joints or planes that takes place, and as a result the overall pressure of the volatiles is slightly reduced, and with the reduction of this volatile pressure sudden dumping of the mineral that is taking place. But you remember, they travel to a great distance, they are associated with the ore body, but to a greater distance. Such liquid is squeezed out, the squeezing of liquid is taking place of lessened pressure. They squeezed out and go to the places wherever the pressure is less, mostly overlying rocks, proportions of the host rocks or into the adjacent rocks. They may be sedimentary rock, they may be igneous rocks, they may be metamorphic rock. Wherever they may find less pressure, they will be squeezed out and forming residual liquid injection. The squeezed out residual liquid from the silicate is termed as filter pressing. This you can imagine, if you take a rice grain which is there in the liquid, put it into their fingers and squeezed out, what will happen? The rice grains will left out in their fingers and the liquid will be squeezed out through the opening spaces between the fingers. Similar squeezing out of residual liquid mechanism is taking place, and this mechanism is called filter pressing. The product is magnetite ilmenite deposit. The best example is Kiruna in Sweden. The residual liquid pegmatitic injection. Pegmatitic injection is a huge injection. The size of the pegmatitic bodies are huge and they are the museums of ores and minerals. All sorts of ores, they are stored in the pegmatites. Pegmatites, they are often zoned. The zoning is often seen in pegmatites. Pegmatites formed by injection of late magmatic fluids, and these late magmatic fluids containing late rock forming minerals along with carbon dioxide concentration, including rare earth elements, mineralizers and metals. The pegmatite associated with felsic igneous rocks, most of the pegmatites, almost all the pegmatites, they are associated with felsic igneous rocks. Pegmatites, they are zoned, as I said you earlier, they are zoned pegmatite bodies, and the zoning is from wall to center or periphery to the core. The zoning is very common in pegmatites. Now, residual liquid pegmatite injection, the important minerals associated with pegmatites are, the best example is mica deposits, corundum deposits, gemstones, all sorts of gemstones, rare earth elements, rare earth minerals containing lithium, cesium, rubidium. The chief metals of economic importance are niobium, tantalum, tin, tungsten, molybdenum and very important element uranium, which is also associated with pegmatites. The best example in India is Nellore pegmatite deposit. Now, we will discuss about immiscible liquid segregation. The 2-sulfide, as I said earlier also, the 2-sulfide rich phases an immiscible sulfide rich liquid followed by copper rich pyrrhotite solid solution, they get separated out. Sulfide rich liquid quenched to mixture of pyrrhotite, chalcopyrite and magnetite. See, pyrrhotite, chalcopyrite and magnetite, they get separated out. The early phase of immiscible sulfide melt, concentrate and copper and nickel deposit. The early phase where nickel and copper sulfides are separated, in the later phase pyrrhotite, chalcopyrite and magnetite phases are separated. So, two distinct sulfide deposits are formed by immiscible liquid segregation process. The best example of immiscible liquid segregation process is pyrrhotite, chalcopyrite, pentylandite, nickel copper ores with platinum, gold, silver, all precious metals and other elements, and these deposits confined to mafic igneous rocks of gabbro family. Form, what is their form? What is the form of the such types of deposits? They are disconnected bodies, they are in the form of small bodies, isolated bodies. What is the mineralogy of these bodies? They are simple and monotonously uniform in their composition. Example, Isizawa type South Africa deposit. And I am showing you a diagram here, which is a generalized diagram of Inziwana type intrusion, black differentiated basal zone carrying nickel copper sulfides. You see, this is the whole igneous body, and at the bottom of this igneous body you get formation of nickel copper sulfide deposits. Now, we come to another category of deposits, which is called immiscible liquid injection. Sulfide rich fraction accumulated and squeezed out towards places of less pressure, such as sheared or brecciated areas, and in these areas sudden dumping of the elements or metals taking place. It consolidates to form immiscible liquid injection deposit. Association of rocks and mineral products of such types of deposit is platinum. Platinum occurs in mafic to ultramafic rocks. No other rock except mafic and ultramafic rocks where we get platinum deposit. And what are the ultramafic rocks? They are mostly norite, peridotite and dunite. Chromite, chromite associated with peridotite and anorthosite. Titaniferous magnetite and ilmenite associated with gabbro and anorthosite. Nickel copper deposits associated with norite. Diamond occurs in kimberlite only. There is no other rock where diamond you will get, that is kimberlite. Kimberlite, that too the diamond crystals or diamond grains are disseminated throughout kimberlitic matrix. Minerals such as beryl, cassiterite, labradorite, scheelite and niobium tantalum minerals, they do occur in pegmatites. Another category, entirely different category, nothing to do with the magmatic deposit, but it is a separate type of ore deposits formed by a different type of process that is called sublimation process. I will discuss sublimation process here. Sublimation applies to those which are volatilized, means volatiles. As I said earlier, they are always present in the silicate phase. Silicate phase rich in volatiles such as sulfur vapors, sulfur dioxide, H2S, carbon dioxides, water vapors, they constitute volatiles, and subsequently these sublimates they deposit under low pressure on surface conditions, mostly on surface conditions. And during the formation of these deposits, very interestingly, it involves direct transition from solid to gaseous state or vice versa without passing through liquid state. That is the most interesting part of sublimates. Sublimation is associated with volcanism. It is always associated with volcanisms and fumaroles. Fumaroles, in the last phase of the volcanism, the volcanic pipes they emit sulfur vapors, and these sulfur vapors, as soon as they come to the surface, they crystallize out in the form of sulfur deposit. So, the best example is sulfur deposit in Italy and Japan. Viewers, whatever I have discussed in this section, I would like to summarize it. Let me summarize what I have discussed. I have discussed about the magmatic process, and my focus was mainly on the late magmatic deposits. Late magmatic deposits including segregation type, injection types. Thank you very much.